Okay, so we are going to be looking at section 5.1.3, which is finding inverses and justifying algebraically. So we're actually going to skip problem 40, and we're going to go ahead and move to 41. So that will be our first classwork problem. So it says to find the inverse of the function of the following functions using your new algebraic method, clearly showing all of your steps. So let's go ahead and review what that algebraic method is. So we talked about this in our last lesson. So the first step is to change f of x to y. And now that's simply just to make it look nicer. So when you're solving, you're not dealing with like two different variables there, even though technically f of x is just one. After you do that, then you will solve for x. Once x is completely isolated, you're going to switch x and y. And your last step would then be to change y to become f to the -1 of x. And the reason for that is that denotes that it's an inverse function. And obviously, if it's g of x, it would be g to the -1 of x. So go ahead and do problem 41 on your own. So you're doing A, B, and C. You're just finding the inverses of those three functions. So you can go ahead and pause this once, and once you finish, you can go ahead and press play. Okay, so we are moving on to 42. So I'm assuming that you have now done 41 on your own. So 42 says, Adriana's strategy for checking that the functions f of x and g of x are inverses is to think of them as stacked function machines. She starts by choosing an input to drop into f of x, then she drops the output from f of x into g of x. If she gets her original number, she is pretty sure that the two equations are inverses. So let's kind of think about what this means like in terms of numbers. So let's say I have a function and I drop in 3, like they're showing on the right. If I drop in 3 and I get out 12, what they're saying is you could then put 12 into the inverse function and you should get a 3. So is Adriana's strategy sufficient? Yeah, it is. Is there anything else that she should test to be sure? She could also go in the reverse direction. So we will go ahead and write that. So yes, I'm going to just say yes, it works. She should reverse the direction or order of the machines, just to be sure. So going backwards. Okay, so part B is now saying with your team, select a pair of inverses from the equations of problem 41, name them f of x and g of x, then use Adriana's idea to test them. So I'm going to go ahead and just use the first function, which was a. So I'm going to say that f of x is going to be 2 times x minus 1 cubed. And for the inverse, which they're wanting us to call g of x, you should have gotten the cube root of x over 2 plus 1. So what we want to do is we want to find, let's go ahead and do 3 like they did in the example. So we want to do f of 3. Now when I do that, I would have 2 times 3 minus 1 cubed. So this would be 2 times 2 cubed, which is 2 times 8, which is 16, okay? So then what we want to do is take that 16 and plug it in for g of x. So we would do g of 16, and we should get a resulting output of 3. So this would be g of 16 equals 3 times 16 over 2 plus 1. So this would be the cube root of 8 plus 1. And the cube root of 8 is 2 plus 1 equals 3. So that did definitely work. Okay, so let's go ahead and look at C. Adriana wants to find a shortcut to show her work. She knows that if she chooses her input for f of x to be 3, she can write the output as f of 3. Next, f of 3 becomes the input for g of x, and her output is 3. Since f of 3 is the new input for g of x, she thinks she can write this process of g of f of 3. Okay, so let's kind of back up. So let's look at the inside first. So they're saying if we do f of 3, we would get our answer. So you can essentially, and I'm going to go ahead and go here real quick. So they're saying g of f of 3 equals 3. Well, you would want to do f of 3 first, right? Well, f of 3 is 16. So what you're really doing is g of 16 equals 3. So that totally makes sense what she's saying. So I'm going to make it simple and just say yes. I will say g of f of 3 makes sense. All right, so let's go ahead and look at part D. So part D says her friend Symmetra thinks she should also write f of g of 3. Is she correct? I'm not going to try saying her name again. Why or why not? So what that's saying is if you do g of 3, if you plug that into f, would you get what you started with? No, that doesn't really make sense. Because if we look at sorry, I'm trying to go back to the screen. Okay, so they're saying if we do g of 3, if we do f of that, would we get what we started with? No. So we are just going to say no. G of 3 cannot be the input for f of x unless she reverses the order. So g of 3 can't be the input for f of x unless she reverses the order. Okay, so moving on to part E. So part E says, will this strategy for testing inverses work with any input? Choose a variable to use as an input to test with your team's function f of x and g of x. Okay, so let's go ahead and look at that. Really what they're saying is, could we, if we chose another number, would it still work? So let's just kind of look at it in our heads. Like if we chose 2, for example, and put it in for x here, we would get 2 minus 1, and I'll go ahead and write this out. So f of 2 equals 2 times 2 minus 1 cubed. So 2 times 1 cubed, which would just be 2. Now, because when I put in a 2, I got out a 2, I'm going to take that output, I should get a 2. So g of 2 equals the cube root of 2 over 2 plus 1, which is the cube root of 1 plus 1, which is 1 plus 1, which is 2. So we are going to conclude that yes, it works for any input. We can keep testing numbers, or we could essentially put in a variable and try it that way. Okay, so 43 and 44, these ones you guys are going to do on your own. So we're looking at a couple new strategies. So we have Statler and Trejo, and they're going to tell you some more strategies. So you guys will do these on your own. So go ahead and pause the video and work on 43 and 44, and then we're going to come back to 45. Okay, so at this point, you should have finished 43 and 44. And remember, you can always check your solutions on my website to the classwork to make sure that you are doing these properly. So let's go ahead and look at 45. What we're going to do is A together, and then you guys will do B and C on your own. So 45 says Adriana was finding inverses of some functions. Use Statler's strategy from problem 43 to check Adriana's work below and test if each pair of equations are inverses of each other. If they are not, explain what went wrong. So remember, his strategy was to essentially plug in one function into the other, and then our output should be just x. So let's go ahead and try that for a. So we have f of x is equal to 3/5 x minus 15, and we know that g of x is equal to 5/3 x plus 25. Now, I can either do f of g of x or g of f of x. Regardless, I should still get x. So I'm going to go ahead and do f of g of x. So what this means is we take this entire function, g of x, and we plug it in for x. Think of it like if I did f of g of 3, I would just take 3 and plug it in for x. Or sorry, if I just did f of 3, I would take 3 and plug it in for x. But this is f of that function. So I have to plug in that function in for x. So what that will look like is we would have 3/5, but instead of x, or instead of like a number, we're plugging in this entire function. So 5/3 x plus 25. So that's our now input, and then minus 15. So what would happen here is 3/5, I'm going to essentially distribute this, right? So 3/5 times 5/3 is just x. 3/5 times 25, that would be 3 times 25, which is 75, divided by 5, which is 15. So we get x plus 15 minus 15. So those cancel out, and we get x. So that would verify it. So that means that these functions are inverses. So if you were to get something that's not x, like, you end up with like x plus 5 or whatever, then that means that those functions are not inverses. So what you guys will do to finish the classwork is to do questions B and C. And we are skipping 46 and 47. So you'll just do those two. And then we are also not going to be doing the math notes because we've already kind of talked a bit about composition of functions. So make sure you check all of your classwork at the end, and that is concluding 5.1.3.